Here we are in Chapter 2 review exercises numbers 12 through 16 with the inequalities. We're going to solve them exactly the same as equations, except when we add or multiply or divide by a negative number, and it will switch the order of the inequality. Okay, we also need to make sure we write it in set and interval notation, so the graph will help us. But we don't actually have to graph it, but I think that'll help us get the interval notation. So subtract 11 and we get 6t is bigger than 6. Divide by 6 and we get t is bigger than 1. Well, there we have our set notation. Do the cute littles around there. Now on a number line, this is greater than 1, so there's 0, there's 1. We'd have an open circle, which is the same as parentheses, like that. Again, we didn't need to put that in there, but that helps us to identify the interval notation is from 1 up to infinity, like that. All right, number 13. Subtract 7, we get 5m is less than or equal to negative 19. Divide by 5, we get m is less than or equal to negative 19 fifths. And yep, right there's our set notation. Let's draw those little braces on there. I'm going to graph it just to make sure we get it right here. 0, negative 19 fifths is down here. And this is a closed dot or closed bracket right there. So that is negative infinity to negative 19 fifths. Open and closed because we include that as an answer. All right, number 14. Ooh, a lot of big stuff here. Negative 3x minus 6 plus 5x greater than or equal to 8x minus 56. So we have 2x on this side minus 6 greater than or equal to 8x minus 56. Subtract 8x from both sides and we get a negative 6x. Add 6 over there is greater than or equal to negative 50. And from there, divide by a negative 6. Now we're dividing by a negative number. That means this is x is smaller than or equal to, does that reduce? Positive 50 divided by 6, that's 25 over 3. And there's our set notation. So we're less than or equal to 25 thirds. If we throw that on a number line, if there's 0 and there's 25 thirds, we're on the small side of it and it is equal to, so bracket like that. So the interval notation would be from negative infinity up to 25 thirds, and that's closed. That's open. We never hit negative infinity. Excellent. All right. Here we have compound inequalities in 15 and 16. So we'll do one of them in red and one of them in blue. So let me see. These guys are already solved. So let's put this on a number line here so we can see what happens when they go together with the word or. There's 0. Here is 2. And here is negative 1. So the red one, greater than or equal to 2, looks like this. And less than negative 1 looks like this. Well, shoot, is there any other way to write that? Or means we can be either here or here. The answer contains everything that's colored, either one of them. And so this is the answer. That's it. There's set notation. And then interval notation would look like this, from negative infinity to negative 1, union 2 to infinity. I don't think there's any easier, nicer way to write that. All right, number 16, let's do the same thing. We have red over here that we'll solve. Gives us 4x is less than or equal to 6. Divide by 4 and we get x is less than or equal to 6/4, which reduces down to 3 halves. Is that true? Okay. Now the other guy, let's put that on our graph here so we can make sure and see where that all is. So if 0 is right there in the middle, and on the red would be 3 halves, so 3 halves. So I'll mark it up above, and it would go like that. All right, so all of those numbers are in the red. Now let's talk about the blue. Add 3 and we get 9x is less than or equal to 9. divide by 9, we get x is less than or equal to 1. So that is about right there, 1, and it's closed like this. And we color in all those numbers. Now the difference here is that this conjunction is and. The answers, the actual answer has to be what's ever in this one and in that one at the same time. Red and blue meaning purple. So all of these guys are colored both red and blue right up to that one. So our answer turns out to be x is less than or equal to 1. Yeah, we can't include the rest of those red ones. So there's our set notation. And interval notation is from negative infinity up to 1, closed. Like that. Alrighty.